once you determine how the star formation rate density of the universe is evolving over, say, the last 11 billion years, and you've actually modeled it with a simple expression, what you could do is, if you know how much stars the universe is forming in the co-moving volume, you can actually integrate it in terms of time, and you can actually predict how many stars there are per unit volume in the universe. For example, is the universe accumulating stars, and when were most stars formed in the universe? Now, if you do that and essentially solve this integral, you can actually predict what is the stellar mass density of the universe from an early universe until essentially today. And this is what this graph is showing. Essentially, the dashed line is a direct prediction from these measurements over here with very simple modeling. On top of that, and I guess to test our own understanding and whether things are self-consistent, what we can do is survey the universe with the same co-moving volumes, but instead of looking at how many stars the universe is forming, we could directly try to measure what is the stellar mass density of the universe at specific times. What we can then do is actually compare the independent observations. We can compare what we would predict for how the stellar mass density of the universe should be evolving with real observations that you see here. And it's really interesting to see that predictions from independent observations and independent observations are actually starting to agree. Of course, one of the important questions that we really need to address is what exactly is causing essentially this decline in star formation rate density, or on this plot, what is causing essentially this flattening? The fact that over the last 11 billion years, very little new stellar mass density has been added to the universe as a whole. One of the curious implications of the decline of the star formation rate density over the last 11 billion years is that we can actually try to extrapolate what we see and predict what will be happening to the stellar mass density, even if we were to wait an infinite amount of time. And it turns out that because star formation rate density is going down very quickly, then even if we integrate it all the way up to infinity, we would only be adding essentially 5% more stellar mass. What this means is that most stars really formed in the past, and even if we were to wait forever, the maximum thing that we'll be able to see would be an increase in 5% of stellar mass density. And that is essentially ignoring the fact that after such long time, stars would actually move away from the main sequence and they would no longer be stars. And therefore, unless something dramatically changes or happens to the universe, then the universe will only form a maximum of 5% more stars, even if we were to wait forever.